Hey folks, we can get started now. Sorry for the delay. All right, so as usual, study hall. Welcome to study hall. Um, the purpose of these study halls is to give you all a forum to ask questions if you need help on a specific thing, and we'll go through it on stream. You can and give you an opportunity to get a little support from one of us here. So. Yeah, and I'll try to go through and explain my solutions as I give them. If you have code that you want me to troubleshoot, feel free to post that, and I'll probably do like a version where I troubleshoot that code, and then maybe a version from a solution from scratch too, and like the way that I would solve a problem, and talk about why. So yeah, that's the purpose. Feel free to put your questions in Slack and include a link to the problems in Learn. And that will help me find them quicker. So yeah, all right. Yeah, don't be shy, but I'm not seeing anything at the moment. So I think we can just go through the material. If I'm going through the material, don't be shy to like ask any questions regarding anything that you want me to go over in the material as I'm going through it, or yeah, if you want me to stop and like explain a concept, something like that. And also don't feel free, or excuse me, uh, also feel free to post any other questions that you have regarding another problem in the thread at any time as well. And that's, that wouldn't be interrupting you. You're welcome to do that at any time. Cool. All right. So we're kind of wrapping up the while loop section here. This says choosing a for loop versus a while loop. So basically, the deal here is this is just going to compare like when to use a for and while loop. Obviously, I suppose that part was very obvious. The idea here is you can and should use a for loop for any problem that it's well suited to solving. While loops can do anything a for loop can do. So any problem you can solve with a for loop, you can also solve with a while loop. But the reason you should use for loops is that they're sort of more contained and they're tailored to the problems that they're good at solving. The problems that a for loop should be used for are any iterative process, any looping process where you know or can determine the amount of loops necessary to complete the problem, to solve the problem. So when you can determine the number of iterations needed to solve a problem before you start looping, then you can use a for loop. There are a lot of problems where you can't, or some problems where you can't determine the amount of iterations necessary to solve the problem until you actually do the thing, right? Until you actually solve the thing, or discerning how many iterations were necessary happens after you've already done the appropriate amount of iterations. So, in scenarios where we can't determine the number of iterations, we need to use a while loop. So let's just look at this a little bit. I think I want to do this. Let's play around with prime numbers a little bit. Let's do a factors list. I'll just write a few functions here, and we'll kind of look at some of them will have for loops and some of them won't be able to. So if I do, actually I'll just do is prime. We'll do is prime. We'll take in n, and we'll say if n equals 2, return true. If n is less than or equal to 1, return false. We'll do that. Do an elif there. And then we'll say for I in range, we'll start at 3 in up to this will be, I'm going to do this sort of minimized range here, int of n to the 1 over 2. So n to the half is the square root of n, and we also want to include that, so we'll do plus 1. And then we'll do steps of 2, right? So we're going to start at 3 and do steps of 2, and we're going to go up to and including the square root of n. Okay. So for this one, we can determine a number is prime if at any point n over I has a remainder modulo, so that's modulo, so we'll say n mod I. So if the remainder of n over I at any point equals 0, then we know that I is a factor of n, and we can return false. If we make it all the way through the loop without stopping the function by returning false, then we know the number is prime, so we'll return true. So just to be clear, I kind of do this, I'm doing this fancy version these days of this function, but you could do range 2 to n, and this will work. It's just a little less efficient. So I'm going to do my fancy version because I like it. And let's just test that real quick. So this is obviously a good problem for a for loop. And I'm going to use I because I'm going to say for I in range. Let's just do 20. Okay, cool. So let's test that. Just want to make sure. Oops, we got some errors. So I think I'm just going to do this then. That should fix that. Okay, cool. I'll have to go back and figure out what I did wrong there, but that's okay. Excuse me. So 0 and 1 are not prime, 2 and 3 are prime, 4 is not prime, 5 is, 6 is not prime, 7 is prime. Yep. Okay, that looks good. Also, I think I just realized what I did wrong. I'm going to try it. So if n, I think what I want to do is if n mod 2. I'll do mod here equals 0. I think that's what I did wrong. We'll try it. No, it's messed up. Okay. Okay, so we'll just get rid of that. All right. Cool. So there's our isPrime function. So this is a good example of when we can use a for loop. We can use a for loop because all we got to do is just check every number between 2 and n. So in this case, we can determine that n, or the square root of n, or half of n, or whatever. There's a few upper boundaries that we could make, but I'm using this one. So in this case, we can determine the number of iterations needed. And this is exactly the kind of thing that I mean by that, right? So this range, range gives me a definite number of iterations. If I have a list of items that I need to iterate through, then I have like a definite number of iterations already determined before I start looping. So in those cases, I can use a for loop. So let's do another one, def next prime. We'll take in n. And we'll do, so for this one, determining the next prime number, there's no way, to my knowledge, and I think this is actually a provable thing, that there is no way to determine the space between two prime numbers without just checking every number to see when you find the next prime number. So the approach here is to just start at n and find the next prime number after n by checking 1 plus n, and then 1 plus that, and then 1 plus that, etc., right? So we can say while is prime n plus 1. Actually, that's not. We're going to need to do not here. So while n plus 1 is not prime, the reason I'm doing n plus 1 here right out of the gate is because let's say if n is 13, 13 is prime number, the next prime number is not 13, it's 17, right? So we don't want to return 13. We want to check. We don't want to check 13 because it's going to be prime. So we want to check the next prime number, or the next number, to see if it's a prime, right? So we check 14. 14 is not prime. Then we check 15. Then we check 16. Then we check 17. Okay, so while not is prime of n plus 1, n plus equals 1, return n plus 1. Okay, so while n plus 1 isn't prime, we're going to increment n, then we're going to check if n plus 1 is prime again. When n plus 1 is prime, then is prime will return true. Not true is false. The loop will stop and will return n plus 1. Because that's the number, and we want to return n plus 1 because we just determined that n plus 1 is the number that is prime, right? Not n plus 1. Okay, cool. So this is a good example of when to use a while loop because, yeah, like I said, there's no way for us to know the space between any two prime numbers. Cool. Okay, looks like we do have a question here. Let me copy this in. So can I please go over the solution to the March 8th challenge number 4? Yeah, we'll take a look at this. Okay. So this one, is kind of a beast, as you can tell. So um, there's a bit to go into with this. I have a solution here. I'll copy paste this in. I will DM it to people if they want it, but I don't really want to like have it floating around and at least outside of a video. So if you want me to DM it, I will. Anybody, just let me know and I'll DM it to you. So I'll go over this and talk about it a little bit though. So the next few object-oriented questions are going to work to build out an object called single linked list, or SLL. This is a kind of a classic data structures sort of question. And then it's got a link to the SLL. We don't need that. Okay, so a singly linked list introduces a few important concepts to OOP. I would say that this is a problem that is typically like taught with OOP. There are ways of doing this. I think that, well, are there? Well, I guess in Python there's not. So yeah, we basically need to build classes because we're building our own data type essentially. So yeah. So we're gonna construct a node. Wait, why is this? I'm sorry, this is hard to get through. Did I copy this wrong? First is a node, okay, so which is a container that stores data. The second is an edge or a pointer. This links from one node to another and allows the programmer to go from one node to another. Third is a controller, which is a class that knows how to use the containers to do useful things like create the SSL or SLL. Okay, I don't want to really, I thought this would help elucidate the purpose of this, but I think the code is actually just going to be easier to just go through like this. Okay, so a single linked list, it's basically, let's see where we can find this. It's a structure where we have like the data and then a link to the next piece of data, which itself holds the data that it has, and then a link to the next piece of data. So here's our node. We have our init method. We're taking in self and object. We're setting two parameters, the value, which is what I was talking about the value, which is equal to the parameter object. And then self.next. So this is where these two are sort of the properties in which those items are held, right? So the value is held in self.value, and then the link, quote unquote, link to the next object is held under the next property. So self.next holds that link. Repr stands for representation. And this will give you, yeah, just prints out the value basically. don't know why wouldn't it print out? I'll print it. I'm going to print out self.next as well. So, and then here's our actual SLL class. Here's our actual data type. So notice it's going to use that node. So here's using that node. We've got another init method. We'll initialize start and end with none. Count equals 0. So this is just going to kind of keep track of its length. Should probably be like length or something, but then we have a push method, which will allow us to basically add a new node, right? So this is going to increment the count immediately, and then we're going to save a new node under this new node variable. Let's see where we're using that. Okay, cool. Here we have two branches of logic. One for if start equals none. So this is what we want to do when we're adding the very, very first node. So on the very first time we're adding it, we're going to say start equals new node. So this is our start parameter, self.start equals new node. And self.end also equals new node. Then we have different logic for if this is the second or any other node, right? Which says self.end.next. Now remember, since we set end to a new node, right? When we did this first branch, we set end to a new node. The new node has a next method. So self.end is this method, but this property. And then .next is the property in the node class, right? So self.end.next equals the new node, and self.end, which is this method, equals the new node, right? So the reason we do them in this order is that we have self.end is currently what's about to be the prior end. And then we access the next and point that at the new node. And we also access self.end again, and we override it also with the new node. So then that way, next time we go through this, we override the next property in that node with the next node, and then override the new end with the next node as well. So hopefully that's clear. I know there's kind of a lot there. I think OOP stuff is like really easy to get it like very quickly lost in the weeds in. So I don't want to like I don't mind giving it some airtime, but I don't want to get totally lost in it. So and I will DM this code to you. All right. If anybody else wants that as well, let me know. Cool. All right. I'm not seeing anything else at the moment. So excuse me. Okay. I'm just going to jump back into the while loop stuff. Actually, no. I'm just going to put a minute on the clock to give people a minute to get a question in if they want. So. Okay, cool. Nobody's putting in any questions, so we'll just go through the material. All right, so let's just go through these challenges. Does the following situation call for a while loop? Write a function that takes one parameter. This function should go through a list. It's a for loop, and raise each number to the power of its index. So I know already it's gonna iterate through a list. A list has a definite size. I should use a for loop for this. I could use a while loop, but why hurt myself? I have too much self-respect to use a while loop when I don't need to. All right, so does the following situation call for a while loop or a for loop? Write a function that does the sums up all, Write a function that needs to go. That sums up all the integers between the two parameters num1 and num2. If the value is even, return the sum is even. If the value is odd, return the sum is odd. Okay. Write a function that sums up all the integers between two parameters num1 and num2. Yeah. So this describes a range to me. Sums up all the integers between num1 and num2. That's range num1 comma num2. So that's a for loop again. Does the following situation, blah, 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 write a function, takes a value, it should convert the parameter number to binary by dividing it by 2 until the integer part is 0. If the remainder is 1, it should add 1 to the binary number list. If it's 0, it should add a 0 to the binary list. Okay, so we're gonna, let's see, write a function that takes a value which should convert a parameter number to binary. Yeah, okay, so this is a dec to bin function. So it'll divide the number, it'll floor divide the number by 2 until having it successively yields a 0 or a 1. If it's a 0, if the remainder is a 0, it'll add a 0. If it's a 1, it'll add a 1. I think we should use a while loop for this one. It should reverse the list and return its number. Yeah. I think we should use a while loop. Yeah. Because we don't know how many times we'll need to divide it by 2. At least in the terms that it was stated there. There might be a way to determine that, but I don't know. All right. Now you have some practice. Write a for with for and while loops. In your own words, create a mnemonic to remember when to use for loops versus while loops. Mnemonic? Let's see. If if number of iterations needed is known before iteration begins, use a for loop. Else, use a while loop. I'll do it like this. I'll make it all Python looking. Okay. Number of iterations needed to solve a problem is known before iteration begins. Use a for loop, else use a while loop. Okay, it's not really a mnemonic, not a mnemonic at all, but that'll do. All right, getting into strings, more on strings. I'm going to skip the overview. I'm going to get into what are strings. So strings are just a string of textual characters. It's Python's way of representing textual information. So we can have like hello is a string. We have a number of ways to declare strings. We can use double tick quotes like this or single tick quotes like this. There isn't a difference between them. It's like so far as Python is concerned, like it's not like one is this kind of string, the other is that kind of string, or one has some feature or something special about it that the other one doesn't. The only difference it might make is if you wanted to say, like, use an apostrophe. Okay, so notice that the syntax highlighting kind of gets a little weird. Let's do it like this, right? So if I do the double tick quotes on top, I just kind of moved that. I realized my text editor is a little bit small here. Let me blow up the text size a little bit. Okay, so if I use the double tick quotes, notice it stays green. It's fine. This apostrophe s is just another character, this apostrophe. But if I use single tick quotes, the apostrophe character is the single tick quote character. They're the same character. So Python looks at this and parses it, and it says, okay, well, you're starting a string here, and it looks like you're ending it here. And then this is an error, right? So this is going to be a problem. So you can do this, but you have to put a backslash in front of the single tick quote to make it an apostrophe. If you put a backslash in front of it, the interpreter will ignore it as a delimiter for the string, and it'll see it as just a character, just like any other character. We could also do that here, although there's no point in it. So same thing, if I wanted to use double tick quotes in the string, same rule applies, right? So there's no problem with using double tick quotes as characters in the string if I'm using single tick quotes to delimit the string, to begin and end the string, right? If I want to do that in my double tick quote string, then I have to put escape characters in front of them, and in order that Python sees them as characters, not as string delimiters. So yeah, that's the thing. That's really the only difference. But otherwise they are equally as much a string as the other. Now, I personally prefer to use double tick quotes because I find myself using apostrophes more often, like when I'm writing something, like in copy, than I am. I find myself using apostrophes more often than quotation marks. So I just kind of standardized to double tick quotes. The formal, like idiomatic Pythonic thing to do is to use single tick quotes. And this comes back down to, yeah, just it's a stylistic choice. Like you don't have to do everything in the most Pythonic way possible, despite what Reddit and Stack Overflow will tell you. What's most important is just being consistent. Like pick you can experiment around, like while you're learning, try something out, see if you like it. But just pick a way of doing things and do it that way every time, and that'll make your code, like the point of stylizing your code is to make it more pleasant to read and write and deal with. So if you're inconsistent, that defeats the whole purpose utterly. So just pick whichever way you prefer and do it that way all the time. Yeah. Okay. Unless there's like an obvious reason to break from it for some reason. So yeah. All right, so by the end of this lesson, you'll be able to identify various ways in which strings can be declared. That's kind of what I just went over. Demonstrate your understanding of the limitations of string. Point out the differences between strings and other sequence types. Use several basic string methods. Use some sequence methods which are supported by the string type. Okay. Excuse me. Okay, so regarding this one, point out differences between strings and other sequence types. So I get what this is saying, but I just kind of want to talk about like the way it's saying it, because this might make it sound more complicated than it is. The other sequences are unambiguously unmistakable as strings. Like you're not going to mistake a tuple or a list as a string if you look at it, right? So, but there are other types that we consider like sequences of information. So a string is one. So we can think about a sequence as being just a collection that has an order. Having an order means that it's always the order that elements are placed in that collection matters, right? Like if I put these characters in this order, and then like I printed out the string. Let's say I save it in a variable called myString, and I printed out the string, and it like didn't come out in that order, then it wouldn't be a very useful type. Now, would it? It wouldn't. It needs to preserve its order, otherwise it's not useful to us. So that may seem like something that's so obvious that like, why would I even mention that? There are other data types in Python that don't, and other languages that don't preserve order. You can think about this like, unordered types are like, an analogy would be like a jar of jelly beans. A jar is like a collection of elements, and jelly beans are the elements in the jar. Like, um, there is no like nth jelly bean. There's no fourth jelly bean in the jar. They're all equally in the jar. So um, that's an analogy. But with strings, obviously, they store their information sequentially, which means they are in order. So other sequence types are like lists, tuples. Just listen to tuples. That's it. Yeah. Use several basic string methods. I guess we'll just get into those when we get into them. Okay. So it looks like they're using the count method, count and len. They're talking about count and len. Sometimes it's useful to be able to get the length of a string. If we want the length, we can get the length by using a len function like this. We can count the number of a specific element. So let's say, I think there's a few e's in here. So let's do mystring.count e. What am I doing? I gotta surround it with quotes. Okay, so this is saying the length is 19 and there's 5 e's in there. I can even do a subsequence, so ER looks like it shows up a couple times. Twice, I think. So yeah, I can use the count method for that. If I try to count something that's not in there, like let's say Z, there's no Z's in there. Count's just going to be 0. So these are two really useful tools for strings, and these actually do work for other sequence types just the same. So you have count and len available for lists and tuples as well, and they come in handy a lot. So in Python, strings are recognized as collections of characters enclosed by either a pair of single or double tick quotes. We can make a multi-line string. So this gets into like multi-line comments, like this. So we can spread out a string like this. And when you use multi-line comments in Python, you're actually just making a multi-line string as well. That's what I have. These little code block switches are made out of single and multi-line comments to be able to turn on and off blocks of code like this. Okay, so this is a string. So again, we can use triple doubles or triple single tick quotes. I can't like mix and match. I can't do open with doubles and close with singles. But I can use apostrophes and quote marks in here, and it won't get confused about that being a delimiter for the string this time. So, yeah, that's that. All right. This is that note on being consistent. You can use single ticks, double ticks, just whichever one you choose. Just mostly, commit to just doing it that way. Obviously while you're learning, like, figure out what you like, you experiment, mess around. But, if you're writing something that you intend to be, um, nice for yourself to like go back and reference, or that somebody else is going to look at, like, you want it to be consistent. That's really the norm. That's like an established meme, if you will. Everybody's like, we want to see consistent stylizing for the most part. There's a handful of string methods with which you'll want to be comfortable. We looked at len and len and count. Count is actually a method. Len is actually a function, but I think they're essentially the same thing, but you need to know which ones are methods and which ones are functions, because I don't know. But I just think about them all as tools, various ways of processing a given type. So there's those two. We also have lower and upper, and let's just look at this. So we have wonky string with a mix of upper and lowercase characters, then lower string and upper string, and I think I'm actually just going to do let's go like this, and we'll print. Also, if you're wondering why I put the spaces in front of and behind the thing, it's just because I like it that way. It's an aesthetic thing. So here's our wonky string as it originally was. Here's our lowercase string. Here's our uppercase string. So when we call .lower, we get a lowercase version of the string back. Now let's see if any of those changed our wonky string. And you can think about this, right? Like if we look at upper string here, right? Upper string is equal to wonky string dot upper. Did that change wonky string? That's the question. Did that change the wonky string? Like, is wonky string now equal to the uppercase version? Let's find out. Nope, it's not. It's still in its original form, right? So this is something about strings. Strings are immutable, which means that the type itself doesn't have any ability to mutate or change its value. This just is what it is. We can get different versions of it. We can get a lowercase version of it. We can get an uppercase version of it, but it's literally a different object in memory, right? So we're sort of duplicating that information in order to get some transformed version of it. The nice thing about sort of immutability by default behavior is that you can sort of count on your data not changing out from under you in a way that you don't expect. And if you do want to change the data, you have control over that, right? So if I wanted to change what wonky string, the variable name, the identifier itself was pointing at, oops, I could do this, right? Well, let's do just a different example. I'll just call this my string. Okay, so that's the same string. So if I wanted to change this into its lowercase form, I could just do lower string equals my string dot lower. Now I have two variables that each hold a different version of this string, right? But I could also, if I still just, like, let's say I don't really care about the casing of this and, I don't mind just losing it or whatever, and it's more important that it's just all in lowercase, then I can also say my string equals my string dot lower. Print my string. We'll print it before and after that. So this is sort of similar to a mutation, but it's not a mutation. It changes the value being pointed at by this variable to whatever it was pointing at in its lowercase form now, but it's not actually changing the variable. All right. Okay. So that's lower and upper. I'll say there's another one that often gets kind of thrown in with these that you'll kind of see in with these, capitalize. There's another one like swap case, whatever. So you'll see other like transforms of these. But even amongst these two, I would say I use dot lower all the time. I suppose for what I use it for, I could use dot upper just as well. Like, it doesn't actually really matter. You could use either or. But it seems to be basically standard to use dot lower. For things, right? So a lot of times you're writing some code and you don't really care about the casing of a string, right? It's irrelevant to you. So one way you can do that in your code is to just use a version of the string where all the casing is standardized, either lower or upper. What I use and what you'll overwhelmingly see is to just use an all lowercase version of the string. To standard that way its casing is standardized, and then you can manipulate its values based on that, right? You might be doing something like, let's say you're going through and you're trying to pull out, you're trying to count how many vowels or something, right? How many A's, E's, I's, O's, and U's, right? If you have capital A's and lowercase a's, you have to handle them separately, but we actually don't care. Like, we don't want to like write duplicate logic. So what we can do is just iterate through a lowercase version of the string. The casing is standardized, so any uppercase A's are going to get counted as A's because we're just going to make them lowercase A's. So that's the idea there. So upper is good to know, I guess, but lower you use like all the time for that. So if you remember one of those, just remember lower. Cool. Looks like we have a question. In the last example, was my string overwritten? Oh, let's see. In the last example, that's this example. Yeah, so my string is overwritten here. So my string is overwritten, and this creates something that kind of sort of feels like mutability. You know, like I can call this method and save its value, and it changed. It feels like it changed, as in, I can reuse this variable as if it's a changed version of it. So that's kind of what I was highlighting there. We can sort of mimic a mutable behavior with an immutable type this way. Awesome. Counting. So strings are sequences, just like lists. Yeah, you're welcome. Elements can be counted. We talked about count. Different kinds of characters. Okay. So, obviously we know that Python has different kinds of data types to describe and to describe different kinds of data, so that it knows how to handle each kind of data in the way that that data should be handled, right? So, it might seem trivial, but like 5 is an integer and 5.0 is a float. The way that a computer handles a floating point number is actually very different than the way it handles integers. Um, some like obviously a float can represent any number that an integer can, but and more, it's also more complicated type, has a higher computational load, and there are other certain limitations. There's a like a largest number that can be expressed in a float. There's a a precision limit, so I can't just add. This is way too precise. Python is not going to be able to understand this. This is far, far too what we say is precise for Python to be able to handle. So it's just gonna truncate everything after about 15 or 16 characters. So suffice it to say, even this example, like we need to tell the computer when we want it to think about a number like a float and when we want it to think about a number like an int. And then there are various places where it will sort of implicitly cast an integer as a float. Like if I do 5, or let's do print 10 divided by 2, right? 10 and 2 are integers. Well, we're gonna go float out. Yeah, 5.0. So that's a float, right? So there are times when a something might change, but yeah, okay. So suffice it to say, sorry, I got off on a tangent there. I know, I did it. I admit it. Suffice it to say, different data types for different purposes. Strings represent information in a textual format. So we can deal with numbers in their numeric format, right? But we can also put them in strings, right? So we can have a string of 10. I call this 10. And I try to print 10 times 2. Am I going to get, or tep, what's this, 10? Tet? 10? Where's my, okay. Print 10 times 2, what am I going to get? I'm going to get 10 and 10, and that's because we can actually multiply strings by integers. This is kind of a funny thing. I wanted to show this particular thing because there are times when you want to deal with the digits of a number, so you cast it as a string, and if you forget to cast it back as a digit when you want to do math, or excuse me, when cast it back as an integer or a float or whatever, when you want to do math with it again, if I'm expecting that number times 2 to be 20, I'm going to get 1010. I'm going to be confused. So if I do this, if I do that, I'll need to cast it as an int first. So notice this operation is possible because, and this is tying it back around, the types of the characters in the string are digit characters, right? So there are different kinds of characters in a string. So I might say, and we have methods to tell us true or false as to whether a given kind of character matches a given kind of character. So I might say, what should I call this? I'll just call this var for variable. So we'll just have this var equals a string of the digit 1. So we'll say, oh, I already did print, string, or excuse me, var dot is digit, digit, parentheses after is digit. Okay. This will tell us true or false as to whether var is a digit or not. If I say var equals a, we're going to get false, right? Because a is not a digit. A is alpha. So var dot is alpha is going to be true. We also have one is alnum. Oops. Alnum. ALNUM for alphanumeric. So is it an alpha character or a numeric character? And so there are other characters. I should do, actually, I don't know why am I, I'll just stick with it. I'll do it this way. There are other characters that are not digits or excuse me, that are not, digits or alpha characters, alphanumeric characters, special characters. Like this. So exclamation point is neither alpha nor numeric, alphabetical nor numeric. So var dot is alnum is false. There isn't a method for like is special character. What you can do is just do not is alnum. So this is like saying is not an alphanumeric character. So if it's not an alphanumeric character, then it's a special character. So that's how you can do that. You can still recuperate that behavior of having a is special character. Method, but yeah. Cool. Oops, excuse me. Okay. Let's make sure I got them. Alpha, digit. Oh, is space. Dang it. Forgot that one. Okay. This is a useful one because sometimes you want to like spaces delimit words. That's the quote character, or the symbol, actually the absence of a symbol. But to a computer, a space character is a character. It is a symbol just as much as any other textual symbol is, right? So is space is a really good one to know as well. Yeah, I think there might be like an is white space for any other white space character, but yeah, I don't know. That's good to know for now. Okay, let's get into this. True or false, the following code represents a proper string declaration? No. So string equals this pair of quotes is going to be an empty string. This is all going to be invalid syntax, and then this is also a valid empty string, right? So we can't do double quotes, or double tick quotes is what I mean. That's not a valid string. We could pare this down, to either be triple double quotes or single double quotes, but not double quotes. It's confusing, I know. So not a valid string, false. Well, the answers are just, I don't know, booleans. The result, what is the result of the expression is digit? Ooh, this is a good one. I believe it's going to be false. So this is a weird one because you think, oh, well, 6.7, etc., right? That's a float. A float's a digit. Like, fair enough. However, when Python says is digit, what it's doing is it's looking at the characters, right? You might look at this and say it's a digit or it's a number, whatever. But this period here is not a digit, right? So I forgot to mention this, but because I was just only giving single digit character examples, but we could have more than one digit character in here. So if I print this, and I did take the period out, right? So this is going to be true because this is a digit, right? But if I add a period in there, if I add a dot to make it into a float, no longer a digit. Write a function called whitespace counter, which should take a single string as an argument and return the count of whitespace characters. Okay, whitespace counter, def whitespace counter, take in text, return text dot count, and then I'm just going to pass a string with a single space in it, and that'll tell me how many spaces are in it. No. Oh my gosh. Oh, I'm silly because, well, they were serious about whitespace counter. Okay. So whitespace characters are the space character, the new line character, and the tab character. I'm not counting either of those, so yeah, that's my bad. So let's just add those in here. Text.count space plus, we'll do that new line, and this will be tab. So that'll be \t is the tab character, which is considered a white space character, and the new line character, which is a literal line break. So when I put in new lines to push it down a line, I'm putting in new line characters. Okay, so it's the sum of those three. No? Okay, wow, I'm really on a roll today. That's great. Let's see then. Tn \v \f. What? Okay, let's see about this. 1, 2, 3, 4, 5, 6. Okay. V, F, and R. There's more whitespace characters than I. Okay, well that just blows me away. I didn't even know about those. Well, there you have it. Now I'm curious. Now you've gone and done it. You've made me curious. Yeah, let's just see what this prints off as. It's interesting. Nothing. I thought so. because of course it's not gonna. Yeah, all right. So I could just add those in, and I think it will. VF and R. So that'll be T \V \F. Oops. \R. Okay, let's try that. Hey, it finally worked. Okay. So now this does make me think maybe I think there is a white space method. Now let's just look up here. Aha. That's interesting. So \R is a carriage return, which I thought was the same as a new line character. Perhaps it's not. To check if a string is all white space, you can use the white space is space method. Okay. Now, I am curious now. I want to try this out. I'm just going to see what string methods are available to me. So I'm going to say dir string. Okay, swap case, da-da-da. Let me get into the is. Is upper, is title, is space, is printable. Okay, so there is no is white space. So I was wondering if perhaps there was a method that would just return true or false for all possible white space characters, but yeah, there's not. So I guess we just have to just handle them all somehow. Now I wonder if I do string dot count, I'll get help on this. I don't think there's a way to pass multiple arguments, but let's see here. Sub start stop end. Interesting. So returns a number of non-overlapping occurrences of substrings sub in string. Start and end, optional argument, start and end are interpreted as in slice notation. So I think that is basically saying which part of the string that we might want to check. Oops, why is it not advancing? Oh, that's the end, okay. So it looks like I can't count multiple things at once. That's what I thought. All right, so for this is just a weird long line of code. I think we could simplify it. So if we did for ch in text, if chn, and I'm just going to do a check for membership of white space \n \t \v \f \r, and then obviously we have a space up front. It kind of weirds me out, so I'm going to put it in the middle. No, I like it up front. Okay, I'm going to stop thinking about it. Then we'll increment our counter plus equals 1, well, the tally. Do it the old-fashioned way. When in doubt, just write an accumulator pattern, and then we'll return tally. Okay, cool. So this is nice. This should work for any white space. Let's see, maybe I left one out, but I don't know. Okay, cool. That'll do. Let's see what they did. Oh, dot is. Oh, I'm so silly. Okay, so this is why I was thinking there's a white like an is white space method, because that's what dot is space does. And I have to relearn this every time. I'm like, well, I want to see other white space characters, not just spaces. I just like take it too literally. So, yeah, ch dot is white space. It's like I have to go through this. I think I've gone through this dozens of times at this point. So I don't know. It's funny. Okay, cool. Can we use grep to test regex in Python for white space counter? Um, grep to test regular expressions in Python for the white space. You mean like import OS and use grep from bash in Python? I guess you could. You could do that. Sounds like a interesting solution. Um, I think Python. Maybe I'm not understanding your question totally, but I think Python has uh, regex support. I don't remember if you have to import it or not. Yeah, I think you do have to import something. I might be wrong about that, but yeah, I know that there's regex support natively in Python one way or the other. Cool. It's probably clear, but I haven't done regex. I haven't done anything with regular expressions, and it's been a long time. I probably should. It was a long time ago, and I was like very new to coding, and I was like, what is this? And I like got into them like enough to kind of halfway hack it, and then I just haven't had to deal with them, so I haven't gotten back into them. But I think they'd probably be much more tolerable to me now. Cool. So basic string operators and methods. I want to do a last call for questions. If somebody has a question, feel free to put it in. Don't be shy. Like that's what the purpose of this is. If I see another question, I'll just stop what I'm doing and take it right away, since we're getting short on time at this point. So, yeah, last call for that. We probably got time for one more if you get it in soon. Okay, so I'm just going to go through this for now. By the end of this lesson, you'll be able to use arithmetic operators to perform basic string operations. Understand string concatenation, interpret code using the operators in the lesson. Cool. Looks like, yeah, somebody's saying they're scared of regex. Yeah. I kind of think it should have been called like irregular expressions. Just saying. But I don't know. They're so powerful though. Like I think it's like one of those things. Like if you know how to use it, like you're virtually unstoppable. But like you can also get by without it, and I don't know. So it's like for me, it's like been on the back burner for like forever. So yeah, they're weird. Okay. Both. So both string concatenation and okay. Let me address these. Actually, I'll do this way. Sorry. Arithmetic operators. Understand string concatenation. Interpret code using the operators in the lesson. Okay. So this might I know what's being said here, and it's not like technically incorrect, but I could see how this could be construed to be misleading. That like it could make you think, oh well, I can use arithmetic operators with strings. You kind of can, but we don't think of them as arithmetic operators when we use them with strings. Earlier, I showed print 10, or let's do it with a non-number. Hello, hello. Okay, well that typo stays. So if I type hello times 3, it'll be repeated 3 times, right? So this is like a repeated, sometimes it's called repetition or just repeated concatenation, where we're concatenating the string onto itself multiple times. So concatenation is the fancy word that we use when we talk about adding two strings. So hello plus world. What we say is that we're concatenating these two strings, right? Let's show a variation on this. Name equals, oops. Okay, so this will say hello Clark. Right, so sometimes we'll call this adding two strings, but the technically correct term is concatenation. So this isn't we're not doing arithmetic because we're not doing this with numbers, we're doing this with strings. We can only use the plus operator and the star asterisk operator for concatenation, or for strings, right? Those are the only two, quote, arithmetic operators that we can use with strings. You can see that that's being demonstrated there. Concatenating a couple strings together. Here we're repeating a string. Yeah, so this is interesting. Repeat string, or rep string, times 3 is equal to rep string plus rep string plus rep string. Since we're doing an equals here, this is going to give us true or false, right? So that'll be true. So remember, if you get stuck, you can always find help in our Slack workspace. If you haven't already joined Slack, you can do so here. So given the code below, what will be printed? So I wonder x, y, z, x, y, z. Okay, I wonder how this will work. So this is, notice how there's no space at the end of the y line and at the beginning of work. So will work will be one word like that. There is a space here. So I wonder space how this will, no space, work. That's the first one. X is 3. 3 repeated 3 times is 333 as a string. Notice that one lacks the quotes, telling me it's an integer, so that's not the one. Write a function called repchars, takes two strings, or takes a string as an input and returns a list of strings as an output. Each string in the output should contain a unique non-white space character from the string repeated the number of times it appears in the input string. Oh, well, I helped somebody with this one recently. Oh, a fun one. All right. I'm not seeing any questions. We're about at the end of where we would normally wrap up. I'll do this one last problem, and then we'll just wrap up there. Okay, write a function, function should be case sensitive. I gotcha. Okay. So print. Cool. Oh, excuse me, case insensitive, right? Okay, so here we have an I. We have two I's because I shows up here and here. So since it's repeated, so we're only going to get instances of repeated strings. We'll take in text, and we will for ch in text, if count of ch, excuse me, so that's going to be text.count ch. If text.count ch is greater than 2, no, greater than, excuse me, greater than 1, we will add it to our list, which we need list equals an empty list. This is the list that we're going to return, so we'll return a list, and we'll say list.append ch times text.count ch. So .count, remember what .count gives us back. It takes in a string. In this case, it takes in a string and returns an integer. It always returns an integer. So ch times, or repeated by text.count ch, just repeats it that many times. We're only going to do this if it appears in the list or in the string more than once. Okay, cool. So this is progress. We have white space. We're missing the I's, and we've got stuff duplicated, right? So let's just take each of those one at a time, right? So white space, duplicates, and what was the other one? No I. Okay, so in order to fix, let's do this first one. So in order to fix that, I forgot the part about case insensitive. So I'm actually just gonna, like I said earlier, use .lower to like standardize case. So I'm gonna standardize case by doing case.lower or text.lower. So text.lower. Let's see if that gives us our I's. Oh, okay, sorry. Text equals text.lower. I'm just gonna do the transform up here because I actually don't care about its uppercase format at all. That's what I should be doing. Okay, so we have our I's, but again, we have them duplicated. Let's take care of duplicates next. So duplicates, so we only want to append if it occurs in the list more than once, and if it's not, excuse me, if ch not n list, excuse me, ch times this. Should I call this? I'm going to be lazy and call it res. Res equals ch times text.count ch. So if res not in list, then that'll tell us we want to add it. Okay, cool. So we still have white space. So we'll do another conditions that gets rid of duplicates. And not ch dot is space. Cool. And I'm just going to kind of cinch this down a little bit. There we go. So just to be clear, what I'm doing here is I always like to, if I have ands, if I have a compound condition that has ands or ors in it, I like to break it down so that each condition is on its own line. To me, that just makes it easier to read. If you do that, though, Python's going to freak out if you just break a line in the middle like this. Since it's a white space formatted language, it's like it looks at that and it's like, oh no, what do I do? So you have to tell it, hey, no, don't worry, it's just a line break. Just ignore that line break and just go on and you pretend like there was no line break that happened. So that backslash just says ignore that line break. Like that. So we'll just do that. So I have to do it in those two places, and then that should work fine. Cool. All right. Well, it's been fun, as usual. Hope everybody enjoyed it. Thanks to the folks who brought in the questions. I think that's really what, that's what makes study halls fun and interesting and useful for everybody. So, yeah, and no worries, like, if you didn't have a question today, but, I do encourage you all to, feel free and bring in your questions for study hall next time if you have them. And yeah, I look forward to next time. Next stream will be on Friday. So I'll see you all then. Go ahead and give the video a like, subscribe if you're not subscribed to our channel. If you want to be notified, and click the little bell icon. You know how YouTube works, I think, at this point. So yeah, y'all enjoy the rest of your day, and I'll see you next Friday. Bye-bye.